Welcome, future engineers, technologists, and innovators. Today, we're bringing you an explainer that is literally going to fundamentally change how you look at the world of manufacturing and automation. We are standing right on the brink of a massive technological revolution, one that's completely blurring the lines between the physical, digital, and biological spheres. It's called Industry 4.0. And look, if you're studying engineering or pursuing a technical diploma right now, this is exactly where your entire career is headed.
So I want you to start by just asking yourself, what actually happens when you give an entire factory a digital brain? Imagine walking into a massive manufacturing plant, but instead of just a bunch of isolated, quote-unquote, dumb machines doing the exact same repetitive tasks over and over, imagine a facility that actually thinks, learns, and acts on its own. A factory that can literally predict when a machine is going to break down before it even happens, or one that can adjust its own assembly line in real time to customize a product on the fly. That is the promise of Industry 4.0.
Section 1. From STEAM to SMART, the evolution of industry.
Now, we've made some massive leaps in our industrial history to get here. Back in the 1780s, the first industrial revolution gave us mechanization driven by water and steam power. Then hit the 1870s, and the second industrial revolution brought us mass production powered by electricity. Think of the very first conveyor belts. Fast forward to the 1960s, and the third industrial revolution introduced computers, IT, and early automation using the first programmable logic controllers, or PLCs. And well, that brings us to right now, the fourth industrial revolution, which started picking up incredible momentum around 2011. This is the era of cyber-physical systems. When you track this journey from left to right, you can see the complexity scale just skyrocketing. Industry 4.0 isn't just about dropping a computer onto a factory floor. It represents the ultimate collision of the digital and physical worlds. We're taking the mechanical assemblies of the past, combining them with the electronic controls of the 20th century, and embedding them deeply with connected IT. It's a completely convergent ecosystem.
Section 2. The factory's digital brain. AI, IoT, and PLCs.
So, this digital brain, it all starts with the Industrial Internet of Things, or IIoT. And listen, we're not talking about connecting your smart fridge to your home Wi-Fi here. This is a heavy-duty, industrial-grade approach. It's how we network all the massive physical machines on a factory floor so they can share huge amounts of data in real time. It takes data out of isolated, clunky systems and makes it incredibly valuable for cross-industry applications. Take a look at the absolute powerhouse toolkit that makes up Industry 4.0. We've got 8 core pillars here. You have those IIoT platforms acting as the foundation. Then we add cloud computing to store and share data globally. We bring in big data analysis and advanced machine learning to crunch those numbers. We've got autonomous robots working the floor, additive manufacturing like 3D printing, creating complex custom parts, and digital twins, which are exact virtual simulations of real-world machines. And of course, the whole shebang is wrapped in heavy cybersecurity. Okay, since you're studying engineering right now, here is the absolute easiest way to wrap your head around how all these complex parts work together inside a smart factory. Just think of it like a human body. The sensors scattered across the factory, those are the eyes and ears, collecting real-time data like temperature, vibration, and position. The PLCs, the programmable logic controllers, act as the nervous system, rapidly carrying those electrical signals and initial commands back and forth. And finally, artificial intelligence and machine learning act as the brain. They take all that sensory input, learn from it, reason through it, and make high-level autonomous decisions.
Section 3. How machines actually talk. Machine-to-machine communication.
We throw around the phrase machines talking to machines, or M2M, all the time. But how are they actually pulling this off without a human operator sitting at a keyboard typing out commands? Let's break down the mechanics of this automated exchange. Here is the precise lightning-fast loop. Step 1, sensors collect real-time data directly from the physical environment. Step 2, that raw data is sent to PLCs and industrial gateways, which process and format the signals. Step 3, the data hits an intelligence layer, either local edge AI or remote cloud systems, which analyzes the data and makes an instant decision. Step 4, the system sends a command back down to the actuators, motors, or robots to execute the physical action. And get this, that entire loop happens in literally fractions of a second. Now, a huge piece of that puzzle is edge AI. Instead of beaming every single data point all the way up to a distant cloud server, which takes precious time, Edge AI brings the artificial intelligence right down to the local devices on the shop floor. The edge device acquires the local data, runs the AI, and makes an immediate decision, like spotting a safety hazard or a product defect instantly. The heavy historical learning still happens up in the cloud, but the real-time split-second reflexes, those happen right there on the edge.
Section 4. Smart robots in action. Real-world factory examples.
I know this looks like pure science fiction, but it is happening right now. What you're seeing is an engineer using augmented reality, or AR. Through a smart device or AR glasses, the engineer looks directly at a physical robotic arm, and the system overlays a digital dashboard right into their field of vision. They can see real-time health metrics, temperature, performance data, and through predictive maintenance, the AI can actually tell the engineer that a specific part is going to fail next Tuesday, allowing them to fix it before the factory ever has to stop. It's a real game changer.
And hey, it's not just stationary robotic arms bolted to the floor. Check out these autonomous intelligent vehicles, or AIVs. Unlike older factory robots that had to rigidly follow painted lines or magnetic tracks, these AIVs navigate completely on their own. They use sophisticated sensors and computer vision to map the factory, dodge unexpected obstacles, and independently transport raw materials exactly where they need to go. It makes internal logistics incredibly flexible.
So you mash all of this together, IIoT, Edge AI, AR, and AIVs, and you get a true smart factory. You achieve mass customization, meaning you can produce highly personalized products on a massive scale without slowing down production. You achieve predictive maintenance, which nearly eliminates machine downtime. And most importantly, you create an environment of seamless, absolutely safe collaboration between brilliant human workers and intelligent machines.
Section 5. Your future in automation. Building the next industrial revolution. Because here's the absolute truth about Industry 4.0. These factories don't build themselves. A factory with a digital brain still fundamentally needs brilliant human engineers to design it, code it, maintain it, and improve it. There is a massive, unprecedented demand right now for STEM skills. The industry desperately needs people who understand PLCs, who can program AI algorithms, who can design digital twins, and who can secure these massive industrial networks. In fact, the source material explicitly points out that Industry 4.0 is driving a growing demand for skilled labor, creating new opportunities for high-quality employment. So forget that old sci-fi fear that robots are just coming to steal everyone's jobs. The reality is that automation is just shifting the nature of the work. It's taking away the dangerous, dull, repetitive tasks and replacing them with highly skilled, innovative, and flexible roles for engineers just like you. So I'm going to leave you with one final question to think about. Are you ready to take your place in the Industry 4.0 revolution? The tools are all out there, from edge AI to digital twins to smart robotics. The manufacturing world is being entirely rewritten, and it's going to be your generation that writes the code, designs the systems, and builds the automated future. Keep learning, stay curious, and get ready to engineer tomorrow. Thank you so much for joining me for this explainer, and I seriously cannot wait to see what you build next.